Hi, everyone. My name's Meg. I'm heading partnership at Blockade, and my colleagues will introduce themselves in a second. But first, I would like to start off with a huge thank you to the Miston Labs team. Sean, Alex, Max, is Rodrigo here? For just really being amazing partners and prioritizing security and protecting your end users. So it's been amazing to work with you, and we're going to talk today about how we can bring all of that wonderful, all the wonderful tools to more builders in the community. So at Blockade, all engineering is security engineering, and we prioritize protecting end users and giving builders tools to detect and act upon anomalies in real time. So today we're going to talk a little bit more about how our partnership with the Miston Labs team and the Sui network is available to you today. So I'll hand it over to Mike and Raz. Please do feel free to ask questions. We want to keep this a discussion, and we'll have a more active workshop at the second half of the session.
Okay, hey everyone. It's good to be here. My name is Raz. I'm one of the co-founders and CTO at Blockade. So as Meg said, we're like a real-time security focused company. Basically, everything we're doing is based on the ability of, given a transaction and the point of view, determine whether this transaction is malicious. So we're helping a lot of wallets to analyze transaction, understand if they're malicious or not. We're helping a lot of exchanges, a lot of protocols, a lot of chains to analyze everything that happens within the application level. And we were fortunate to work with Sui and bring value in the security areas. And hopefully you'll find what we're presenting here today is super interesting. If you're building on Sui, whether you're like a wallet, an exchange, a protocol, feel free to reach out to us. We're working really hard now on Sui and being Sui compatible. That's a fascinating ecosystem. So please don't hesitate to reach out to anyone from the Blockade team, including myself.
Oh, actually, if you want to hear more about Blockade from the man who built it himself.
Hey. Yeah, so as I said, we're a real-time on-chain security platform. I think we can just go forward based on what I said earlier. Yeah.
I'll just quickly add that we're really fortunate to be working with many of the amazing players that you see here. And essentially, as Raz was saying, we're welcoming Sui into the Blockade network, whereas every threat that's detected across this network immediately gets propagated to all of our partners. So imagine if there's a Coinbase or a MetaMask user that's interacting with potential malicious address, malicious token, that information immediately gets propagated across the Blockade network that you just saw in the previous slide. And yes, I think that's good to...
All right, I'll take it over from here. All right, so hi everyone. I'm head of solution engineering at Blockade. A little bit more about stats. These are just the things that we throw on there. So these are the normal big numbers that you see a company brag about. But the reason we can say these are real numbers is that we've integrated with so many wallets across so many ecosystems that when we say we prevented $8.9 billion in thefts, we actually mean just transactions that are going through the majority of wallets in the ecosystem. And we see so many potential attacks happening every day, from scams, rug pulls, drainers, that we're often blocking a lot of them just by telling user, hey, what you're about to interact with is in fact a scam and you should not sign this transaction. They don't sign that transaction, we consider that an attack blocked. So that's where a lot of these numbers are coming from. It includes a lot of dApps we're analyzing, transactions we're scanning, tokens we're analyzing, and now we're adding Sui to this long list of things that we're working on. So the agenda that we're going to have today is we're going to talk about some of the common attack vectors we're seeing in the Sui ecosystem. These are a lot of things you see in the broader Web3 ecosystem, but we'll share a few specific Sui examples that we've seen. We'll talk about general best practices for how you're developing dApps and doing, having a good security development lifecycle. Just out of curiosity, in terms of the people in this room, how many of you are building a dApp or a wallet or some piece of infrastructure on Sui by a show of hands? 1, 2, 3, 4. All right, 5, 6. Okay, sweet. So, and if at any point you have questions or you want to dive in deeper, feel free to raise your hand. I can hand you a mic or just kind of talk it through real quick. This is supposed to be a fairly collaborative session. We have a small group of people here, so we can make the most of it. Then we'll talk a bit about what Blockade is doing on Sui, like what are the sort of protections we're providing with the partnership we have, which actually makes a lot of this available to teams. And we can work with you and then the partners that we have at Sui and Miston on making it available. It's something where we actually have a lot of these things that might be available to you directly as a package. And if not, then we certainly have like full chain support for Sui. And then we'll talk about just some case studies of like other chains we've worked with, how the impact has happened before in terms of like really reducing the number of thefts and fraud occurring. Then we'll just like jump into like general on-chain practices and then do a Q&A and open discussion from there. If we have extra time, we can wrap up, but I would say like if you have any questions, please present them because we want to be able to use this time effectively and make sure that everyone leaves here with a clear idea of what we're doing and how you can do better security. All right, so we'll start with some common attack vectors in the Sui ecosystem. I want to like stress these are things that we see usually in every Web3 ecosystem. So we're going to kind of approach it from like hey, these are things we see everywhere, but here are specifically like how it might apply to Sui and examples we've already seen. Have a few interesting like sophisticated attacks like time of check, time of use that we'll get into as well. All right, so first, malicious dApps in terms of this is basically just a website that is going to attempt to drain your wallet. This is probably the most common thing you see across every ecosystem. Has anyone in this room ever interacted with a malicious dApp before, or someone tried to get them to interact? 1, 2, 3, 4, 5, 6, 7. Yeah. Okay, so there's a lot. So yeah, has anyone ever been like rugged by a malicious dApp before? Okay, yeah, 1, 2, 3. Okay, yeah. So same here. There was one point where I was I think I was like following someone on ZK Sync, and it was like an airdrop, and I was like, I think I know this guy, and there's like some sort of thing he said I should sign up for, so let me try it. And I had like a wallet on my phone with like maybe $100 in it, and then I signed it, and then immediately all my money ran away, and I was like, oh wait. If I looked closer, I saw no wait, that's not the same Twitter account. It was like him with like a different or like a typo in the name, and so. I just wasn't paying attention. I mean, I've been working in the security industry for like 5 years now, and I still got rugged. So I can only imagine how the average user feels when they wander into this ecosystem. And these attacks are very sophisticated. They are usually disguised as legitimate activities. Like, there's lots of airdrops that are legitimate in the ecosystem, so it's very easy to fake an airdrop or to say, hey, sign up for an airdrop and maybe you get tokens. So there's a lot of FOMO that you can rely on. That a lot of people are already used to, exclusive giveaways, or the app just posing as a legitimate service. I did a lot of work on Compound before joining Blockade as part of an audit company I was a part of, and so there was a point where like the DNS got hijacked. I think they actually did a migration from Squarespace, and so for several hours, if you went to the Compound website, the actual URL, you would be presented with a website that looked just like the Compound website, but would actually, as soon as you signed any transaction, it would immediately drain your wallet. So. They try to get in anywhere if they do a Twitter domain takeover, DNS takeover, or they just do a lot of phishing and send you links to things and hope you click on it. So it's just the fact that like if you can get a user to sign even one transaction, you can potentially get if not hundreds, then maybe thousands or even millions of dollars with the right target. So it's something where this has become a very sophisticated industry, for lack of a better term, within the Web3 ecosystem. And when we say industry, we're not just talking about people that are getting more sophisticated about creating drainer websites, but also people franchising the creation of drainer wallets. So there's many drainer operators and threat actors that we've seen. CryptoGrab is one example, but there's tons of others. Angel Drainer. And they're basically operating a drainer as a service model where like the best drainers in the ecosystem don't actually build the websites. They create a software kit that they will then release to people on the dark web or in Telegram groups, and they'll have a fee sharing model. And so when they release it out, they're basically going to, and they have very sophisticated setup pieces. They literally have a UI that says, is this how you'd like to drain wallets in this particular way? Do you want to configure this particular option? And then when they release it out, they basically can then like have 20 or 30 different teams take this drainer kit and then just figure out whatever opportunities they have and then combine it with other exploits. So maybe like they get connected to another group that is able to figure out how to hack into Twitter very effectively because they've gotten good at that. And then another group got really good at tricking people with really convincing looking airdrop emails. And so you have a ton of different actors that are all using these same drainer kits and then disseminating them. And this is why this is such a prolific thing. It's not just one specific group and that's doing this, but like multiple drainers and service models that are almost like kind of competing with each other and then building out their own network of people that are releasing these websites. So that's the reason that this is so prolific, it's so constant. And so it's literally like an entire industry that we're basically having to fight back against to protect legitimate users that are in the Web3 ecosystem. And this is why we need to have very sophisticated solutions. It's something that the Miston team's already been working very hard on to protect against, and now Blockade's coming in to also provide some of the solutions we've built. We'll talk more about how we integrate, but the main thing we do is just try to flag domains as quickly as possible, ideally before they've even started to rug users. One of the advantages of the fact that there's this drainer as a service model is that there are similarities. If you're using the same drainer kit, there are software signatures and code signatures that we can rely upon to detect and say, like, this is a drainer website because we've seen this sort of a Web3 connection before, or this sort of a software piece embedded in the client code. There's other things we know about that we can extract addresses and say this is a malicious address, don't connect to that. And Blockade constantly scans every domain that is registered on the internet. We detect if it's potentially a Web3 website, and if it's a Web3 website, we run additional detections on it. We basically like fuzz the heck out of it and poke lots of buttons and try to figure out if it'll present a transaction to us and show us other details that we can use to determine if it's malicious, so that by the time a user tries to interact with it, we're integrated with wallets, including Miston and others, that are basically going to tell you, hey, this is a malicious domain, don't continue interacting with it, and hopefully prevent the attack from even proceeding further from there. And we'll get into more like examples of how exactly we're integrated with the Sui wallet and others. And this is specifically protections that we want to present to all of the wallets in the Sui ecosystem, so that ideally we basically tell drainers, this is not a profitable ecosystem for you. Like, the more protections you have in place, the more that drainers will not target an ecosystem that doesn't seem like it's fair play. They will move around like locusts, and kind of reminds me of like Independence Day, where they talk about the alien race that just moves to different planets and soaks up all the resources and moves to another. It's basically like that, but for like different cryptocurrency ecosystems. And so if you have a lot of protections in place, if you have like the Will Smith that's, you know, in a alien jet and is able to blow up the mothership, then you're able to kind of prevent them from wanting to come back. And the idea is hopefully Blockade can give you those sorts of protections. Another area that is often used to rug users is, well, fake tokens and rug pulls. So this is very common to DEXs. We've seen some on Turbo Finance, for example, in the Sui ecosystem, but we've also, of course, seen this all over the place. This is a very common vector that's, you know, been around for many years in the crypto space, but it has gotten more sophisticated and common over the last couple of years. You know, Trump coin and what was it? Malay coin and other, like, now that, you know, presidents are getting involved, it's definitely become a little bit more popularized. But the model is typically the same. It's either a token that is impersonating a known token. So you might have something that's pretending to be USDC or a legitimate Sui token or something else, getting you to buy it, thinking it's valuable, you know, for the, you know, valued the same as this legitimate token when it's really just worth nothing because it's just a copycat. But we see other examples of like someone starting a new token. It's like a meme coin. People think it's going to go to the moon. And then someone has basically set it up to immediately rug it as soon as enough value comes in. And some of these rug pulls can happen very quickly. So for example, this one to the right was pumped and drained over the course of a week. So that's a fairly, I would say, medium-term cycle we see for rug pulls. We've also seen other rug pulls in other ecosystems, including Solana, that will happen in the course of hours. Like, we will see the token deployed and registered. It'll be like maybe 10 minutes later, we'll start to see rug pull activity, and then 30 minutes later, it rugs the community. So the life cycle of some of these can be incredibly rapid, which is one of the reasons you have to have like security detections that can happen, that can basically move just as quickly to detect the sort of patterns we see. One of the ways we'll often detect it is just looking at the like actors on-chain history and see if they've already done prior rug pulls before. That's one easy way. You would think that they would mask their on-chain history, but in many cases they don't. So we can see that in some cases we'll have a single group or actor that has done over 100 harmful tokens that are all basically being created through the same on-chain trail. And we can see the contracts along the way that all exhibit the same pump and dump pattern. So this will commonly keep up coming, and we'll detect it not just through this vector. This gives us a lot of confidence, because if we see you've already done a rug pull, we're like, yeah, the next thing you do is likely going to be a rug pull. I don't think we've seen any cases where a rug pull decides to suddenly deploy legitimate tokens later on. They like that pattern a lot. It's pretty low effort and high value. But we'll also see other things like, hey, we see that the way the liquidity for that token has been set up is in such a way that they're able to basically, you know, quickly dump and pull it out. We also see other patterns of how they're like acting on chain. So we often, like in our detecting, we have a token detection tool that's also available for the Sui ecosystem today, and it basically will return a result to you and say, hey, is this a malicious token? Is it a token that has some warnings you should be aware about? And we have two specific ones on rug pulls. One is honeypot, which is basically like, hey, the way that the supply distribution and other things set up on this token are high risk for a honeypot. Doesn't mean for sure it's a honeypot, but it's very likely it's a honeypot. And then we have another one that's malicious, which is rug pull, which is it's definitely going to rug. Do not let a user interact with this, or at the very least tell the user they're going to get rugged if they interact with it. And this is something we've integrated with on a lot of major DEXs. For example, Uniswap, we have a full class support there, and we basically have a flag on every token that someone interacts with on Uniswap that would tell them, hey, this token is malicious. It's in a permissionless protocol. You can't stop tokens from being listed there, but you can tell tokens if that token has potential harmful quantities so that they ideally don't interact with it if they don't want to get rugged. If they do want to get rugged, then they're have at it, or take at least the risk of knowing there's likely a rug. And by the way, are there any questions as we keep going? Okay, sweet. At any time, feel free to raise your hand. Okay, the next one is where things get really interesting because one of the things that we've seen come up a lot to fool common ways to detect malicious transactions is what's called a time of check, time of use exploit, or TOC, TOU for short. So basically, in a lot of cases with protection, including blockade, but also other software out there that will simulate the result of a transaction, it's usually the easiest way to say, hey, does it seem like there's anything malicious in this transaction? Like, well, let's simulate it and let's see what the result is, how much money leaves my wallet, how much money comes into my wallet. If it doesn't, and then present that to the user. And if the user's like, hey, that's not what I expected, they don't sign the transaction, which normally is good enough. However, what we've seen is that as threat actors have become aware of the fact that people will simulate their transactions, they will realize that, hey, what if there's a way I can fuel the simulation so that when the simulation happens, they think that it's safe when in reality there's a way to circumvent it. And the way they do this, in simple terms, is a user will sign a transaction after they see a simulated preview that says, hey, this is benign, it's going to do what you expect. And then between that simulation and the on-chain execution, the attacker is able to alter the contract state, introducing some sort of a flag that would basically suddenly, their normal route was this is how it's going to work, normal transaction, and they changed the transaction call route to, okay, now it's just going to send all the money to the attacker. So they can detect, hey, the simulation's happened, now let's switch it. Now that they think it's safe, so the time of the check is a simulation, the time of the use is when the transaction is executed, and the time of the use is when the money is actually going to go to the attacker, which bypasses these traditional security checks you'd see for just normal simulation. And this is something we have seen specifically in the Sui ecosystem, but we also have seen it in a lot of others like Solana and Ethereum. So this is kind of the flow. User would connect to the wallet. And then at that time, there's a command and control server, which is to say just like a server controlled by the attacker that's kind of helping to coordinate this, that would prepare a drain transaction or detail. And the object is going to have target details. And so when the user clicks the claim button, they're going to run that simulation. And then as soon as that simulation runs, the command and control server is like paying attention. It sees when that simulation has been run. It's like, okay, great, they're running the simulation. As soon as that simulation is done, let's make sure we update the state, which is just going to like do a transaction call on the contract, change it out so that now, instead of it being A for safe, it's B for rug or drain. And then when the user actually submits the transaction on chain, they'll lose the asset. So it's a fairly sophisticated attack vector. It's one that's very difficult to track down, but it is something that Blockade's gotten good at now detecting and simulating, mainly by looking like deeper on the contract level and seeing like, are there potential vectors in here where they could be like changing a flag to alter the transaction flow. And this is a specific detail where you can actually see how it's embedded in like one of the move contracts, where you can see that there's specifically an area where you see the address of the spender, and then you can see there's a time of check where the simulation, the user transfers assets to themselves, and then the time of use where that argument can be turned, and then the transfer then goes to the scammer wallet. So this is like one of the examples we've seen. Go ahead. Yes.
Do you think this is solvable, or is this a cat and mouse situation? If you just set a flag, it seems like you just check branches and you can probably detect a malicious route. But you can make it arbitrarily complex that you interact with many different contracts, and you have to actually set a string that will only then reveal a malicious route because the assembly code, whatever, is encoded in a way that you cannot see what it does without the string or the key being set. Like, is this a cat and mouse game that is not solvable, or do you think at some point with machine learning stuff you can solve this?
That's a good question. The short version is, at least for now, this is something that we've been able to detect and solve. And part of what Blockade does is we don't have static solutions. We just constantly pay attention to the threat landscape and then update our detections accordingly. So as soon as we saw this occurring, it was something we were able to, and by the way, occurring, this is before we even came to the Sui ecosystem because we saw it in other places, but we were able to say, hey, this is something that we're going to have to make sure we check for, not just naively running a simulation, but also checking the contract details themselves to see if there's alternate paths. And it has been something we've been able to tackle that way. In terms of like the long-tail scale of like, are there ways for attackers to make it infeasible? Potentially. I think it's something that we can overcome if that does come up. I don't know, Roz, if there's anything you wanted to add.
Can I compliment you?
Sure.
Hi, Reginald. So for Sui specifically, there's an advantage that all your inputs are inputs to the transaction. So you can detect the pattern just by the balance of the coins that are in the input of the transaction. So you can tell the user, oh, up to 1,000 Sui is in game here for this transaction. So it's a cat and mouse game. It always is, but there are things that we can mitigate. Yeah. And Blockade has been doing.
And Roz, do you want to add something?
Yeah, I think just to summarize, so first of all, I think security is always like a cat and mouse game. Like this thing is a reactive response of an attacker to like mitigation that is done. You know, we always have this race. And you have a lot of ways to like try and detect it. So, for instance, there are also other examples where the attackers are using like OS codes, like seeing like the gas price, seeing timestamp, or like block number of transactions. So you can try to sign this type of behavior. You can also, we started to sign, you know, the on-chain behavior of you had a contract and you see one like single actor that tries to like front run the transactions all the time. So I think it's a cat and mouse game. It's good because what we've seen in other ecosystems as well is that the attackers, they're playing it to a certain level and they say, okay, it's like too much for us to invest now. Let's move to a different ecosystem. That's what we usually try to do.
Yeah, we try to make it so hard that they're like, we're going to go to something that's an easier target.
Yeah. So I also have some comment here because we are building it like long before. Yeah, and basically from attackers' perspective, that you are actually performing this action depends on like you need to inject a transaction before using transaction. For example, currently the most transactions are signed by wallet and submitted by the dApps. So it's giving the attackers some time to inject their own transactions. But if like the suggestion way is that submit the transactions through wallet, like what users say, what users submit, so it can prevent this from happening because the attacker, they cannot ensure that they turn the switch before using submitting the transactions. Yeah, this could be a solution for those cases. But on the trade-off is that, for example, if users want to see their balancing being updated directly in the dApps, because they are connecting the different phone nodes, it will be a latency for them to see the, for example, balancing updates. Yeah.
Gotcha.
Can you pass it to your?
Yeah, we also do some observation. We noticed that according to our observation, the attack is done by the sponsor transaction. So the attacker will have more time to inject or do something on the contract. And this morning, I have discussed with the consent engineer team and say whether on the wallet side or on the other side we can set a much lower, for example, transaction expire time, so that it can limit the time for the attacker to do some attack injection. Yeah.
Yep. No, that's a good point. And we had a question in the back. Could you pass it back?
Maybe you answered it partly. So partially, I was thinking about how it's possible that the attacker knows that dry run is made, but I think it's only possible with sponsor transactions. Either that, either it has to be validator which runs it. So basically, only thing when it can happen is during the sponsor transaction. Am I right?
With non-sponsored transaction, you can raise, but then you have to actually raise. With sponsored transaction, you don't need to raise. you know when the user signed, and then you sign. Because it will sign on your web app. The user will sign on your web app, so you get the signature. So you know.
You can potentially like build a contract that says if the block number is below that, do nothing. If it's above that, take away the user function. As Reginald said, like
And update regularly that block number, yeah.
exactly.
So you just switch and just wait for someone to fish in. Yeah. Okay.
By the way, just one more thing to add. So like that's why this thing is called like time of check, time of use, like very known for their ability type. And if you think about it, like if you want to solve it logically, I think you asked about it. So the cat mouse game is like it's good now, and like we can get above these attackers. But the problem it starts from like there's a point in time where the transaction is evaluated, then there's a window of time, and the transaction is executed, right? So the logical solution for this is maybe connect these two and do the validation on chain in the same point of time. But these are like usually more complicated, require gas, just like something to think about.
Yep, good questions. Yeah, and I guess pass it back to Russ. So. All right, so the next thing I'm gonna do is just go through the development lifecycle for building dApps. This is something fairly generic that I have like done and educated people on when I was working at OpenZeppelin for security. So my biggest thing there was making sure that when people showed up for an audit, they had actually done everything necessary to be prepared for the audit, as opposed to giving us a lot of really crappy code and hoping that it came out clean at the end of like a 2-week time window. But then, now that we're working at Blockade, we're much more focused on like the production point. So this is when you're actually deploying your code to production after your audit, and then continuing to operate it and make sure it's secure, as well as like making sure that end users, the way they're interacting with either your code or just the general ecosystem, have some sort of protection against potential threats like drainer wallets and others. So I'll go through every stage. These are things that might be obvious to some of the people in here, but maybe filling some gaps. So first of all, something I'd recommend, doesn't happen a lot in the Web3 ecosystem, but I encourage it, is to develop a threat model in the design phase. That's to say, before you actually start writing code, start to consider like what are the threats that you intend to prevent, like, what is in scope, what is out of scope. So there might be, for example, you're building, let's say, something like Uniswap or a DEX, and you're basically like, what are the sort of things that this DEX should be able to do, and what are the things that we're not going to consider in scope. So Uniswap will be like, well, you need to be able to do a swap, and you need to be able to exchange one asset for another, and that needs to be secure. There needs to be no dependencies. If you're building it as an immutable DEX, you want to make sure there's no dependencies on external oracles or other things like that. But you might not be caring, for example, about malicious tokens. You're like, hey, if someone lists a malicious token, on Uniswap, it's not going to be considered a risk to the protocol. It's going to be down to just making sure that like that particular like swap pool is isolated from all the other swap pools, so it's not going to have any sort of like system-wide effect. But it's down to the user at the end of the day to ensure that they're not interacting with a malicious token or a malicious trading pair, which is where you would look for other solutions like end-user protection. But at the end of the day, the protocol itself is not considering that a vector. So when you're talking about like permissionless systems, it's definitely important to know like what do you as a protocol intend to solve as a problem, and what is going to be considered kind of out of scope, so that when people are auditing it or considering the risks of interacting with your protocol, they know what to expect. Like, hey, the protocol should be guaranteeing this, as opposed to other things that are considered to be like a risk that I as a user or like another software that's integrating with that protocol need to evaluate independently. And then generally planning for controls, like what are you going to be protecting against, and assessing throughout the process. Like what are their tests and unit tests going to be checking against, what are your auditors going to be checking for, and then what are you going to be monitoring for in production. So like a lot of the things we talk about in the rest of the lifecycle will be driven by the threat model. The threat model can be as simple as just writing these things down. It also could be as complex as like defining these things as mathematical variants that you'd use for something like formal verification. The latter is nice to have for sure, but some teams at the end of the day, you have to build it in a certain period of time, and you can't fine grain and define everything, or you just need to figure it out as you go. But generally having at least something written down for a threat model that evolves over time is incredibly useful. The next thing, of course, is then you start to do the development. You're starting to build this out as like a Move Smart contract, or potentially also a lot of the other software that's integrated with it. So you're also possibly building a front end and other things that are going to work alongside it, maybe also a back end. So generally speaking, like make sure that you're defining like what are going to be privileged functions. If your protocol on chain is going to have some sort of like authorized actor or admin, if you're integrating with an on-chain oracle, if you're integrating with other protocols that are also upgradable, just considering like all of that and then making sure you have a least privilege enforced. So some protocols will just say we'll give one account that's maybe a multi-sig, like complete control of the entire protocol. And have access to every privilege function. But ideally, if you can, especially if these are going to be separate things, like one power is for minting, one power is for doing an emergency pause, maybe try to separate those powers out and have different accounts control different things, especially because they might have to respond within different time periods. So the minter might be like an average daily operational thing. You want to have maybe a super admin that can revoke control of the minter at some point. You might also want to have a pauser that's controlled separately. It's a very important power to have that needs to move quickly, but you also don't want to like pause right off the cuff. And generally speaking, if you have different people or teams involved in this, you don't want them to all be working from the same account or key. So having that split out and defined in the protocol ahead of time is really important. I know this is really challenging to do with Solidity after the fact. If you just set a super owner and then later on you're like, oh man, we really should have defined different roles and permissions for this. And then you have to do a really messy upgrade. That's not ideal. Versus having a lot of things defined ahead of time. And then using trusted libraries and standards. In Ethereum, when I was working at OpenZeppelin, this was something that we definitely encourage people to do is like, hey, use this library, don't reinvent the wheel. In Move, you actually have modules and other things that are actually defined on chain that you can pull from, which is even nicer. So definitely encouraging teams to make use of that and just look up and say, like, before I define like a new piece of logic to define access control or a token standard or something else, that there's already a module that is out there that's already been audited, it's already been kind of battle tested. Go ahead and use that instead of reinventing that code. It'll not just save you time, but it'll probably be a lot more secure. Testing, pretty straightforward. Do a lot of testing, but also if you can, not just unit tests, but fuzzing, which is basically just, if you haven't heard of fuzzing before, it's basically like throwing everything in the kitchen sink at your function to see what will cause it to fail. If it's like giving it a number, giving it a hexadecimal, giving it like all kinds of potential inputs that might cause it to suddenly freak out in a way you didn't expect. So fuzzing is a really important one, especially with property checking, where you can kind of define exactly what you expect it to be able to handle, what it shouldn't be able to handle. Again, something that can be driven by threat modeling. You also do simulations, just simulating how these transaction results are going to work, which we will do in production for user transactions with Blockade, but it's also something that's really valuable to do in your testing phase as well. And then also documenting all the expected behavior, using comments and validation checks to show clearly what you intend your code to do, what you expect to work and what not to work when you're interacting with it. So again, these are things that are really helpful for your auditor. And by the way, once you actually have the code in a state where you think it's ready for production, and the key thing is you think it's ready for production, not, we'll let the auditor get it ready for production. That's not their job. Make sure that you do actually go to an auditor and get a good conducted review. That's generally considered to be a best practice, and especially if your protocol is going to be managing potentially millions of dollars. I know there are some teams in the space like OtterSec and others that have started to provide audits within the Move ecosystem specifically, but generally speaking, just make sure you have a reputable auditor. They've done it before, they know what they're doing, and that they're going to produce a report that will give you feedback on what to improve. Hopefully you go in hoping you don't have any issues. But if they do have issues reported, you make sure you fix them. You make sure you state your intent around why you fixed them, what the problem was. If you're not going to fix an issue, if you think it's like something that's, again, like out of bounds or something that's, an expected risk for the user to take on, it's not something you consider the protocol's problem, just document it very clearly so it's very clear. And then also audit your deployments, which is to say, like, great, you've gotten your code audited and it's considered to be clean, it doesn't have any more bugs, but is that the same version of the code that you're releasing to production? I can't tell you how many times I've seen someone get their code audited and then someone decides to do a couple of quick features before they actually release it, and then, oh my God, there's a bug in there. And everyone thought the code was audited. No one actually checked if the git commit matched exactly what was deployed versus what was stated in the audit report. So I highly encourage you to make sure that your deployment is what you're getting audited and that you've already gone through all the feature development that you needed at that point. And even better, if you can include the auditor in your deployment process and have them look at not just the audit, but here's the exact script we're going to run to deploy it. There are also cases, I don't know if there are gotchas for Move, but I know that in Solidity, if you're doing a contract, a gradable contract, there are sometimes ways that you have to initialize the contract upon deployment that can create security issues if you don't do it properly, which might not be obvious by looking at just the code. You would actually have to see how the developer intends to deploy it directly. So definitely would encourage you to think about your deployment as part of the code that needs to be audited as opposed to something separate, because there can be things that slip in. And then finally, when you're deploying it, making sure you're ready for going to production immediately. So one thing is to have like a bug bounty program or something similar set up where if there are security issues, people know how to reach out to you. Bug bounty is ideal, and when you have a bug bounty, put it everywhere. Put it in not just like on your website and in your GitHub, but put it in the source code if you can, especially if that source code is going to be published and viewable on a block explorer. Just put in a little email or a link to the bug bounty program to say if you find a bug, if you happen to be perusing through this code and you find a bug, this is where you should report it in a secure and responsible manner. You don't want a white hat to be in a position to say, hey, I found a bug in this code, but all I know is the contract address. I don't actually know where the team is located. I don't know what their email is. I don't know. So they end up just messaging random people on Telegram saying that there's a bug in your code. And you might have a third party reach out to you, say, hey, this guy's going around saying there's a bug in your code. You should maybe reach out to them. Ideally, there's a very clear path for them to immediately come to the security team. I can't tell you how many times someone has reported a bug through the BD guy. They know, the business development person. They're like, oh, well, this is the only person I know from this team. So I'm gonna tell him about the bug. Hopefully he knows what he's doing and reports it to the right person from there. So generally speaking, this is gonna be something that you wanna have set up and clear. And again, bug bounties are ideal because then you're incentivizing people to report bugs to you and get paid. But even for some reason you're not able to afford a bug bounty at the time, at least have an email or something like security at your domain, something like that. And then of course, being prepared for runtime issues. And this, from a monitoring perspective, means you're logging all the important events, especially if there are changes to access control or others. Have things around error handling, recovery paths. This would not just affect smart contracts, but also any of your production code on the back end or front end. So if suddenly money is going out the door and you don't know why, I don't know how many times I've also been in war rooms where someone's like, hey, show me your logs. And they're like, oh crap, we didn't turn on logs. We don't know what happened at that time in terms of our internal infrastructure. Naturally, you can at least look at a block explorer for a smart contract and get some details there. But ideally, if there are other systems happening in parallel that you control, the back end and the front end, you want to have some logging and some other D-shells that you can prepare so that you can debug these things very quickly. A lot of good teams will probably already have this, but it's important to be aware of it. Oh, question. Yeah, and are you from an audit company? Constamp. Okay, nice. So yeah, another auditor if any of you need help. In general, these are things that I've done the same thing at OpenZeppelin where I was reporting this to people and saying, hey, these are things you need to do, and they're like, yeah, but we need to deploy in 3 weeks. So the best you can do is at least educate them. And if you don't have as a good security resource on your team, then talk to your auditor early. In fact, that's best. Not only will you probably get good insights from them early on, but you'll probably be better prepared for the audit, and you can get the timing and the scope ironed out a lot cleaner as opposed to going to the auditor last minute and hoping they have time in your slot to meet your deployment deadline. Generally speaking, talk to your auditor or any security resource you have as early as possible to help educate you on this process. All right, and then the final thing, which is just once you've done your deployment, you're in production, how you operate that code is going to be really important. So from a monitoring perspective, going beyond just basic logging is going to be having the actual ability to detect potential security exploits. Looking at things are users suddenly losing a lot of funds all at once? Are there any unauthorized ownership changes, especially for access control that exists on chain? So you can detect if someone's key has been exploited or there's some sort of access control bug in the code itself. You want to know as soon as possible because often there are ways to react and mitigate damage even if there is a hack already occurring. I think there were actually not just one but 3 different separate hacks that we were able to detect at Blockade on Arbitrum last week. Or at least one of them was on Arbitrum. And these, I think all 3 of these attacks were in the same case where the attack started where someone was able to steal batches of $5,000 to $10,000 at a time, but then they kept looping through it and they kept stealing more and more and more. And while if you could have detected the initial one immediately and then immediately paused the contract, and at least one of those contracts had pause capabilities, you could have probably prevented like 10% or 90% of the funds that ended up getting stolen. So even if it's only just to detect that the hack is occurring, there's often ways that means you can mitigate. And there's also cases where you could even detect it before it occurs. So like if you see a contract that's going to be used as part of the exploit deployed and the system can detect that, which at Blockade we are able to detect that often, not all the time, but often. That also gives you an initial reaction to say, okay, let's get in, figure out what's going on, potentially pause. Maybe you still have to do some team assessment. Hopefully you have someone on call. Of course, you also want to make sure this is hooked up to an alerting system, possibly a pager system if you have one, and that's going to go a long way. This is obviously an area where it's just one of many things that you should be putting in place to provide protections, but if you have millions of dollars at risk, every single little bit counts. And then finally, in terms of user protection, if there's something your protocol is not protecting against, but there are threats out there, such as malicious websites that are impersonating your website. Obviously, you have no control over a malicious website if it's registered, but if you can provide some way of protecting the user, either through the wallet or other things, then that goes a long way to ensure that your user will be safer. And especially like showing details about the transaction and warning about risky actions will also be really important. And we'll talk more about the last 2 points because that's what Blockade is offering in the ecosystem for Sui today. Any questions on this before I keep going? Go ahead.
For example, politics to get into regulation of these topics. Would that help, in your opinion, or do you think it's better to let it to the technical side and solve it like that?
So your question is, will regulations help security?
Yeah, kind of.
Maybe. It depends on the regulator. I think the one challenge I see with regulations is like, who's going to write them and are they going to be like requiring things that make sense? I've been part of discussions around like what kind of regulations do we see coming. Right now, the regulations are super high level. Most of them are just like, if you're someone issuing a stable coin or somewhat being a centralized operator, you should be regulated as like a money service business or something like it, which makes sense. And from that point, you should have the sort of security protections you'd expect for any sort of financial technology company. For permissionless applications, I don't think we've seen any regulations that really clearly say how these dApps should be building to be secure. It's usually just down to a question of like, is it a security, the financial security or not cyber security? It could. I think it's just going to depend on who's in the room. I think I've been working with the Security Alliance, which is a group of hackers that are working on like not just threat prevention and responding to incidents, but also figuring out like what sort of standards should the industry have. And ideally, I think the ideal path will be for the industry to self-regulate and say these are good practices that you should be following if you're a project, and we would just kind of name and shame projects that don't follow them after a certain point. And the regulators see that and they're like, okay, it seems like they're somewhat taking care of this within the industry, or they just default to what the industry's already developed as a standard. So I think that would be the ideal path because I don't see very impactful or useful regulations coming from the top down, unless there just happens to be someone in the policy world that knows enough about this industry to give good recommendations. It's very possible they might hurt as much as help by just hampering the ability to develop the software or putting really stringent requirements like you have to get a SOC 2 audit before you deploy on a blockchain or something crazy like that. So yeah, it's an open-ended question or open-ended answer, I guess. But I would say I hope that the industry self-regulates and that it becomes kind of the default as opposed to having to come from a government that might not know as much about the technology. All right, let's keep it going. And then, I had to throw the fun graphic in there of like, it's a life cycle, which means that there is rebirth, which means if you're monitoring for things in your production or things in your operations that you realize need to be improved, it turns into the whole process again when you plan it out and deploy recurringly, which means that, you should be planning for this process to be recurring as you push out more updates and push out more changes. This is, I guess, especially important to emphasize in the smart contract world where a lot of teams build thinking like, great, we built it, we've deployed it, it's immutable, we're done, we walk away. When in reality, this is still a piece of code you have to maintain and keep safe and potentially be ready to push out bugs or just general feature improvements. And so you have to make sure this is a process you're ready to repeat. All right, so now let's talk a little bit about on-chain monitoring for dApps and just some of the things that we recommend. A lot of this is kind of based on what we've seen in other ecosystems, but I did have at least one slide in here that talks about Sui-specific things that might be a good idea. But some people in this room might know more about Move than I do. In fact, I know some of you definitely know more than I do, so if you have any suggestions, I'd be happy to hear it. So generally speaking, this is kind of like how we think about it for like a 3-step process. Like ideally, you should be monitoring specific things that you care about. What are the smart contracts that are within your team scope? That might not just be smart contracts that you've deployed, but smart contracts you depend on. So this definitely happens a lot in Ethereum, but I imagine in Move as well, is where you're like, hey, we've deployed this DeFi protocol, but it relies on these oracles. It has listed these tokens. So even though these are contracts that our team doesn't directly control, we want to keep an eye on them in case there's something that they do that will impact our system. Obviously looking at any treasury wallets you're managing, any EOAs, which is to say accounts in the term for Move. And then maybe even looking at like the network itself, validators or sequencers or bridges, especially if you have funds that are being bridged over that you care about. So generally speaking, just have like a wide list of everything you'd care about and have it documented, have it part of your monitoring stack. And then what do you want to detect? We have a lot of out-of-the-box rules for Blockade, but there might also be things you want to configure yourself. But generally looking at like, is there a smart contract that's been exploited? Are there multi-sigs or privileged accounts that are approving things that you just want to generally always know about, even if it's something that is benign? You know, if your access control or admin is only processing a few transactions every month, then, you know, getting a big alert every time would probably be good, even if it's just to confirm, yes, it did what we expected to at the time we expected it to. Because if you get an alert on that and then everyone on the multi-sig's like, that didn't come from us, then, you know, you have a problem. Looking at collusion attacks, potential MEV, if that's a factor, front running, liquidity anomalies. Again, it really comes down to like what protocol you're building, but just know what you want to detect for. And then what the really important part is like once you've detected something, how are you responding? It could be just as simple as like firing an alert or making it part of your logging stack. But if it's specifically something that you know is going to result in a security issue, or is at least something you want to investigate, you know, wanting to make sure your security operations team is aware. There are ways you could configure like multi-signatures. Like we have a cosigner module that will actually prevent a transaction from going through the multi-sig if it doesn't go through the proper approval process or certain risks are raised. You can also do things like unwind positions or revoke approvals or do on-chain actions that are going to like immediately reduce your exposure to a potential attack or some sort of error. And you can also like, you know, do something as drastic as pause a contract if you think and you have enough confidence that this is a security issue that you need to immediately respond to and reduce damage on. And the example I gave before, there have been several examples recently where a contract exploit was ongoing for 30 minutes, an hour, where pausing immediately would have mitigated a lot of the damage. So being able to pause the contracts quickly in response to your monitoring flagging something is important, and that you actually have a process to do it very quickly. Even if it's not automated, you at least have a team that's ready to show up and authorize it very quickly. And then even doing things like reaching out, notifying third-party wallets, which this is something Blockade does a lot today, where if we detect a contract exploit and someone that is integrated with our system sees that an exploit's occurred, we're going to tell users, hey, don't interact with this contract. There's an exploit occurring to mitigate a lot of potential damage that occurs. Okay, so this is some ideas I have for what to monitor on Sui. First of all, tracking critical object ownership and access. So if you see any object transfers, especially for shared upgradable objects, you probably want to know. And then alerting when critical objects change hands. So if the recipient's new or unverified, or just maybe it doesn't matter, like you still just want to know if it changes hands. Based on what I've learned about Move, this seems like a really easy one to start out with. Just anything you care about, you want to know if the object ownership changes. Tracking module publishing and upgrades. So modules are kind of like a really cool feature that I wish Solidity had embraced, but who here remembers the parity multisig hack on Ethereum back in like 2017, 2018? Yeah, it was bad. It was like this one multisig that everyone was relying on, and then the code got upgraded, and a massive vulnerability got introduced, and then like hundreds of millions of dollars got basically frozen out. So Solidity, everyone in Solidity, even though they still copy paste from the same library, which is OpenZeppelin, they don't trust on-chain libraries. It's really weird. So I like the fact that Move actually does have this enfranchised, is like just using modules and being able to like pull from this existing code template. But obviously, if someone's managing that module and publishing upgrades, you want to be able to keep an eye on that and know about it and make sure that that's never something where someone might have done a malicious upgrade. You also want to look for abnormal object mutation patterns or things that allow changes to objects that might not be expected, and just looking at like atypical execution paths, and then generally just logging and analyzing abort codes or custom errors. Since you do have error codes that occur on Move, you want to know anytime an error is happening. something you definitely want to log and then potentially flag an error for or an alert if it's something that matches a potential critical issue. And just looking at that as a general problem to look at. So yeah, this is some of the ideas that I had just based on what I've learned about Move so far. By the way, there are other people in our team that are digging deeper into this ecosystem and know much more than I do, but they're too busy building to come here and tell you. So if any of you have ideas, I'd actually be interested to hear it. If not, then that was my attempt to try to mine some free info out of y'all. All right, now we'll keep going. But yeah, does anyone think that any of this doesn't make sense? Or there are like ways you would word this differently? All right, okay, yes. Wherever the mic went.
Wait. Yeah, I think it is good, and maybe we can discuss it more specifically. For example, how about this package is a dApps? Yeah, before the Sui, we have witnessed that there is another attack on the Epitals that they gen another dApps, and that is not only about the upgrade capability, but they find something to gen the money from the pool. How do you do it? How do you monitor such online attacks? Yeah.
So, yeah, sorry, say it again.
I think that it is good to monitor the upgrade cap and other things, especially the admin cap. But I think that maybe it is not that enough to protect the protocol itself. We have witnessed that there is another attach case on the Epitals that it is a dApps and it is generated by the hacker. They generate the money from the pool. But yeah, and on this case, how can we monitor the pool and protect the asset of our users?
Okay, so yeah, so just restate. So you're talking about like how do I monitor for like potential like a pool being drained by an attacker?
Yeah.
Okay, gotcha. I think it comes down to like the details. There's probably like an easy, naive, out of the box way, which would just be like looking for large outflows. And of course, this is going to be something that's going to be responsive to an attack as it's occurring. So ideally, this is a case where when you see these outflows, there's still a way for you to be able to respond and mitigate it. And there have been attack vectors where it's a repeatable attack where they're kind of draining more every block. But there's also cases where it might be just a one and done, which is not great. So there's also, I think, more ways you could look at. For example, is there a contract that they're deploying that they're going to use to initiate this exploit? And can you detect that malicious contract? There have been cases where we at Blockade, as well as others, have been able to detect a malicious contract when it's been deployed. And when it's targeting another address, we can look at the bytecode, we can analyze, and using both machine learning but also other techniques to say, hey, this is matching like a likely attack vector. And we see that it seems to be targeting this specific address that like would correspond to your protocol. And that would be a good way to say, okay, this is something we need to respond to. It might be pausing the contract. It might be doing something else. But that would be a way to get early warnings. And then outside of like monitoring for unknown outflows, monitoring for potential malicious contract, I think it would also come down to like when you are developing the protocol, are you aware of potential like edge cases that could occur with that pool? And are there ways for you to monitor like early detections for that? That just comes down to, I guess, the particular protocol and being able to say like, hey, if we see these function calls or these events or these particular patterns, we want to fire an alert. And that would come down to like a custom monitoring solution for that particular protocol. So those are kind of like the three things I can think of. They're not going to be 100% covering every single potential case. There's always going to be potential gaps. But that's probably where I would start. And then I think like you're going to get the most valuable things from like defining the invariants of your protocol and then monitoring for things that might break them. That would hopefully give you a warning ahead of time. And even if it gives you a warning at the time, it would at least give you the chance to mitigate damage. Oh, and Roz, you want to add it?
I think just like, if I understand it correctly, you're asking about like saying, okay, monitoring operates is good and like third parties like code dependencies. But if I understand it correctly, you're also asking about assets, right? You're saying my users, they have assets. These assets are not mine. They're like, I want to protect them from their assets to be interacting with other things, right? Or I misunderstood it.
You have mentioned that now you use the money outflow to distinguish the jailer and attacker, right?
It would be like if there's anomalous outflow. Like this is like not a normal like level of outflow we see.
Maybe it is a very useful way, but maybe there is another way. For example, maybe the users, the attacker, they can use some other variants or other object to do the genre. And maybe if you want to know more how to distinguish the attack money outflow from the normal users withdraw, and how with that information we can better get more reliable alert.
So one example, and this is where it would be a custom invariant you define per protocol, but like one thing we did for Compound, I was building a monitoring stack for them way back, and it was basically down to like, okay, you have a C token or you mint an ERC20 token to represent someone's position in the protocol, and anytime that someone is pulling money out of the protocol, there should be a C token that's coming back and getting burned. So if that event is not occurring, so if you see an outflow that isn't corresponding to a burn event for a C token, then you know that there's there's a core invariant that's been broken. Like there should never be a case where someone's withdrawing money and they're not burning a C token. So that would be one case where you could very confidently say there's something going wrong here, and there's like definitely a need to alert the security team and potentially like initiate a pause or something else. But that's why I say it will really come down to the specific protocol, and that's where teams themselves, again, based on their threat model, their test cases, other things, would want to like define the specific monitors that matter for them. Or if it's common enough, if there's like a standard of how people build DEXs or how they do bridging or something like that, you could possibly have like a template for how a lot of people should monitor if there's like a lot of code patterns that they reuse. Because like, for example, a lot of people would fork Compound in the EVM world and reuse it. So we did build monitoring that a lot of other teams were able to take advantage of and tweak to their own needs. But yeah, it's a good question, and it's one of the areas that's most challenging for monitoring, which is like what is going wrong specifically for your protocol might be different for another protocol. But you can start with something out of the box and then get more accurate from there.
Yeah, so it's a case-by-case solution.
Yep.
Hi. I would like to know if what is the role of AI in things you do, and what could be the role of AI agents, like automatic monitoring, like whatever comes down to your mind when we talk about AI, but I believe that there is a big role,
It's one of the many tools we use. I think it's probably most applicable to detecting contract exploits on the bytecode level. So being able to say, like, looking at this bytecode, it matches the same pattern we've seen in past contract exploits. So we have a large database of past contract exploits, exactly what the bytecode looked like for the contracts they deployed to do the attack, and then being able to like have a model that's very finely tuned to detect if those patterns are reused again. There are other areas where we sometimes use it. We'll sometimes use it for like poking around in a malicious dApp website and trying to get it to produce a malicious transaction. We'll use AI to get around like anti-bot protections in those cases. So that's another area where we use it. But I think that the bytecode recognition is probably the most common. But we try not to over rely on it, obviously, because we think that like having specific heuristics that a security researcher has defined to catch this vulnerability are always going to be better, and they're also going to be more confident, because then you're not just saying, well, the AI thing said this is bad, which will always, if not result in false positives, definitely result in people being at least skeptical and not wanting to trust that to respond to an alert, versus like, no, a security researcher defined this rule and we're very confident that there's a security issue. And so when we do use machine learning, we try to use it in the context of a security researcher, like training the model and defining it and making sure it's very accurate before we deploy it into our monitoring stack. And this is how we use it in our out-of-the-box rules.
And LLMs? Do you use LLMs?
Yeah. Correct, Roz? Yeah.
Maybe I can bring more depth to the question. So do you use automation, or could you use automation using AI agents to monitor, to be kind of installed and run, and check the transactions, check everything else, to interpret whether this is a security breach potentially or not? You see what I mean?
I think so. And you're talking about, because we will do this for like any like contract exploits in general. We will like monitor the whole chain, we'll alert, and then we'll also see if there's a specific address that's been targeted as part of that. And then if you're a customer and you've listed out your addresses and you've said these are the addresses we care about, we would specifically send you an alert and say we've detected a potential contract exploit. or a potential contract that's malicious and is going to be used for an exploit, and we know it's targeting you, and you need to know about it. In terms of like a generic AI agent that's like, give me your code and I'll tell you what to detect, we don't currently do that today. It's something that we've looked into, and we might have at some point. I think the biggest challenge there is just making sure that what it does suggest is useful and high confident. You could do it potentially like on a code base, say, given this code base, what should I monitor for, or other things like that. But the challenge, of course, is just making sure you're confident in it. And then, a lot of people, even teams, would potentially just kind of naively put it into production. And then if it fires too many false positives, then people don't care, they don't listen. And like the last thing you want is something that cries wolf too many times, and then people don't use it when there's actually an exploit that occurs.
I think
that was my general answer, but yeah.
I think we should bring solutions that bring down the cost of security monitoring down, and because probably to employ your team costs a lot of money, and maybe you can have like agents operating that you can sell for less, so make the whole space secure. And these agents are your agents, but can serve much more projects than one security team could serve. So that's where I'm heading to.
Gotcha. Yeah, and we have things that would work out of the box that would be like you could plug in and they would work automatically. So that's where we probably place our machine learning, because we can be very targeted and focused about it. And like maybe at some point there's also a way to recommend custom rules based on what an AI agent would tell you. I think we're not at a point where we're doing that today, but that might be something we do in the near future.
Thank you.
Oh. Let's read.
No, go ahead. You already got it.
Because you talked about AI, I mean, the problem with AI is it needs training data. If we haven't explored and moved long enough to find the exploits, then we can't train. I use AI to write my contracts, to validate my contracts on EVM, and I've passed audits, and like they've come with really good, like there's still stuff that an auditor will find, but like the baseline stuff is gone at the very beginning. So I think as we build more in Move, when we get more in the wild cases, that will actually help with the training part. But like the framework you put there, like I just typed it in ChatGPT, and I have a template right now that can tell me like, okay, when I give some code, use this, and that can be a first pass. But I still don't have in the wild exposure to see like what ingenuity humans would come up with to give me examples of what to train for later. So.
Yep, that's a good point. We'll do him next, yeah.
I have two questions. First, a keyword is about the randomness. Yeah, how do you monitor like some randomness guessing or like randomness collision?
That's a good question. That's something that you could probably configure for. I guess like when you say randomness collision, you're talking about like this thing. The random generation is becoming deterministic in a way that would present a vulnerability, like something like that.
Something like that. Yeah. Just
okay.
It's just question. Yeah.
That's an interesting one. That would definitely be like a very custom detector. I haven't built monitoring for that particular sort of vector. It's definitely something I've checked for in an audit where it's like, have you set up your randomness in a way that would be deterministic or not? I haven't done it for production. So I guess my cop-out answer would be like, I would check for it in the smart contract code initially and make sure like, this isn't a vector you're introducing. If it was something where you really are just like watching it for it in production, I don't know. It's like you almost have to write something that would like kind of fuzz the randomness and like see if it ever comes up with like a different result, or look at the random generation and see like if it ever comes up with the same result from different outputs. I don't know. Or different inputs. It's a good question. I don't have a clear answer to that. I think my cop out is check for it as a bug before you deploy it to production, but maybe there's a better answer someone else has.
I see. Yeah, because I also don't know the answer, so I just want to bring it out to make everybody like attention for this, because I remember Sui, it happened once on some like gambling protocol. Yeah. And my second question is how do we monitor like maybe like small unit or like precision issues, like make it have some loss? Yeah. Do you get my question?
Yeah, so precision issue. So basically, it's like you're calculating out to like decimal place, and then the calculation is like leaving off change or something like that.
Yes.
That's a good one. I mean, really, I think that would be like detecting, like having monitoring running off chain that would like kind of be doing the math separately from the smart contract and then coming out with like a different result. It's not super efficient. I think that I know this has been detected before. It depends on how the contract is being developed, but you could say like, hey, if the balances are not ever equaling out, like looking at the final result of this transaction, it's clear that like this didn't add up to the same result. There seems to be some value that's been left over somewhere, it would come down to like invariant monitoring. Like, if you're pulling money out of a vault, then the money that you've pulled out should always equal the amount of money that went down in the contract balance. And if you see that it's not exactly equal out to the decimal place that you have available, then you would definitely see that there's an issue and there's being like something that's being siphoned off at some point. There's also something that I would hope to like check for in like the initial deployment part, but from a monitoring perspective, that's why I would look for it. Is kind of defining like a specific invariant that you monitor for in production and see if it ever is violated.
Yes, thank you so much.
So I think you have a question as well?
Just to complement on the point of randomness, if you're on Sui, just use the randomness beacon.
So you're asking if the randomness beaker breaks?
They use Sui randomness, but they still have bug.
There is a bug, which is when you have a win-lose situation. If the lose part costs more gas than the win part, then the attacker can just put enough gas so that they will always win. That's the bug. So it's not a bug in the randomness. It's a bug that when you're using randomness and you have a win-lose situation, like a gambling site, you have to make sure that the loss and the win gas are balanced. So if the loss costs less, then you don't have this problem because then you have gas enough to lose. If the loss costs more, then you might have gas enough to win but not to lose. But this is like, we widely publicize that. Auditors know about it. They know about it now if they didn't. But yeah, that's the issue. It's not in the randomness beacon itself. Not being random is in the gas, in how the gas composition of the transaction works.
And that's something that could be like checked for in an audit or like prior to this.
Yeah, and you can actually model that. Like, if it's a loop, you can see, if this loop runs n times, the loss will cost more than the win, for instance.
Okay, neat. All right, any other questions? All right, sweet. I'll keep it going. Next I was talking about is the response part. Like we've talked a little bit about what you could detect, what we could monitor for and move. A lot of great ideas, so thank you for those. The next is like what you do when you have something that's detected and what are the workflows you have. Ideally, you want to automate as much of the response workflow as possible so that you reduce the time to respond. The simplest way is at least to just alert and let someone know like this is occurring and make sure that alert gets to the right person. So having alerts that go into a chat where you have your security professionals sending out emails, customer support channels, potentially also using pager systems like PagerDuty or OpsGenie. So they're waking, it's waking them up in the middle of the night, making sure that it gets over their phone if it's on silent. I've been on security councils before, and like we always set up a pager system that just will basically like get through all of your phone's silent defenses and just make sure you get woken up. Ideally, you have multiple people in rotation. If you're obviously this is not something every team will have, but if you are like, I remember talking to the Chainlink team and they were like, they had a multi-sig where they always had like someone in every time zone that would always be awake and on call for these sorts of things. So if you have enough team members and you're sophisticated enough, you can have an on-call rotation that is ready to respond 24/7. And it's always someone who's like up and ready, not just being woken up in the middle of the night because you're always going to be a little bit sluggish if you're like literally hopping out of bed into a critical emergency. But make sure that someone is there that can respond to a security incident. And then it comes down to what you do. There are some things you could automate or like preempt. So for example, even if you don't want to maybe block an address in response to what a monitoring detects, you might want to like maybe have a block address thing prepared with the red button, basically ready to push when someone can look and validate, yes, this is in fact something we want to respond to, or you can just automate it entirely. And this is something that like we at Blockade do for how wallets are interacting with malicious addresses or contracts. We've also had cases where people will build like API automated workflows for revoking approvals. So if you've made approvals to a contract that's been exploited, you can immediately revoke that permission from them. Sometimes we even have cases where like a contract is integrated into another contract and they have a way to actually like, kind of pause interactions with that specific contract or like, cut off their dependency on it, at least for a limited time. Not a lot of teams really plan for this in the smart contract world. When I was on Compound or working on their security, they had issues where there was like a god-awful week where the whole protocol was like paused for Ether transfers, and we had a lot of teams that were built on top of Compound, and they're like, we built our smart contracts without any ability to respond in a case where our integration with Compound can be kind of mitigated. Like they were just kind of like hanging out in the wind, hoping that our system was going to be able to recover okay, which it luckily did. But you never want to be in a situation where your entire security is like dependent on an external partner. So think about like what happens if one of our critical integrations goes down, and how are we going to like have the ability to respond. When it comes to like how we've done this at Blockade, we have the ability to do, based on our detection platform, it can immediately respond with like, hey, send an alert, do an API call, do an on-chain reaction. So, and then potentially like set specific conditions. So like if you are able to detect, hey, this particular part of this market or this particular contract is having issues, if you've built like an on-chain pausing system that can be specific, you don't have to pause the whole protocol. You will pause just a specific portion or specific functionality. That can be a lot better because then you don't have to necessarily like, shut down your whole protocol. You can specifically pause a specific functionality that makes that decision a little bit easier to make in an emergency, because no one likes to pause if they can avoid it. So having the ability to be selective gives you a little bit more flexibility. And then, for our part, we also would, in our system, if we detect an exploit, we would not only alert you, but we would also block it in every wallet we're integrated with. So that's another big advantage and a big reason we're trying to integrate with every wallet in Sui. If you know a wallet on Sui that's not integrated with us yet, let us know. We'd like to talk to them. And generally speaking, that would also help a lot with your user base not, being impacted directly. And then, at the end of the day, this is what I was talking about is protecting end users, just making sure that we're surfacing alerts to users about potential malicious transactions or contracts. We tell them, hey, you shouldn't sign this because there's an active exploit, or this is a drainer wallet, or any other factors of things, or just simulating it and saying, this is what the result of this transaction will be. This is how the funds will move in and out of your wallet. If they don't match your expectations, then maybe don't sign it. So giving them as much insight as possible and like very clear security alerts. Don't just say, hey, signing an unlimited approval is risky. But people do it all the time. So you have to be very specific. Like you are signing an approval to a known malicious address, do not sign it. So giving them as many details as possible about why something is risky goes a long way, as opposed to something that's very generic. Because then like an attacker could say, hey, they have false positives all the time. Just sign it. It's just like it's your generic warning. It comes up all the time. So scammers, especially ones that are like actively conversing with the victim, will try to convince them to get around it. So like you have to be very specific sometimes with like what you're telling them not to do and why you're telling them not to do it. And this is just some examples of simulation validation we do on wallets with MetaMask, where you can see the simulation here, and then we can also see the alert that comes up. It's like, hey, we see this as a malicious address. You might lose all your funds. Don't interact with it. In this case, it's just a token transfer for USDC, but this could apply to any other sorts of examples. A quick case study of like how we've done this before with Stellar. So with Stellar, when we initially started talking to their ecosystem, they had the majority of transactions on their chain that were effectively malicious. And a lot of it was coming from a single threat group called QSI. And this was causing a loss of around 2.3 million a month. And again, the majority of the transactions on the network were literally malicious. So the majority of their activity was malicious. And so we did an integration with their wallet ecosystem, and those losses were dropped massively, and the malicious transactions went down to less than 20% on the network. So we had a drop of at least 40%, and then continues to go down further from there. So that's just one example of like, you can have an ecosystem that is in a very bad place, and then that can be quickly reversed if you just start with end user protection in the wallet. That's not even counting like the other potential mitigation factors like doing on-chain monitoring and things like that. And this is just kind of an example, if I can play it, of just how that looks. If you're, I think in this case, just connecting to a malicious dApp, there's just like one of those generic airdrops. Hey, sign this, connect your wallet, sign this transaction for an airdrop. It'll be great. You'll get all this free money, and then it comes up with an error basically saying, hey, this is a known malicious dApp. Do not proceed. Pretty simple. And this is the same thing that we're also working with the Sui team on. Sui team already had, by the way, to their credit, building in malicious dApp detections. So this is something where we're basically able to augment their existing database and a lot more to it. So if you're using the Sui wallet today, they will detect a malicious dApp. They'll tell you, hey, there's a malicious domain, and warn users about it. So we're integrating to this. We're adding to the data set. We're enriching it. And this is something that we're also rolling out malicious transaction detection for. That's live today. We're working on integrations. And then we're also going to be working on malicious token detection and a lot of other things, as well as integrating this capability with many more wallets in the ecosystem. This is just like an overview of all the solutions we have. We talked a lot about on-chain monitoring already, but this just kind of gives you an idea of what it actually looks like in our platform. This also, like literally as of today, is now live on Sui. So we're just now talking to teams about trying to get them on board. But one thing we show is like just at a high level, what's going on in your ecosystem, how are your users being impacted, are there any particular scams or airdrops that are happening that you should be aware of? And then if you want to go into specific details on a transaction, it'll show you a little bit more about like, hey, why is this transaction malicious? Who's involved? Who's impacted? What are the particular function calls? These are kind of like Ethereum specific examples, but we now have the Sui ecosystem with Move support provided there as well. And then you can also see some like specific insights around like, who's involved in the fund transfer, the flow of funds, what dApps have been involved, things like that. And even potentially the call stack, which can be very helpful if you're trying to go deep and there's multiple contracts and nested transaction flows involved. Okay, so we've done a lot of Q&A, but I think we're now at a good point where we still have like 38 minutes left. I think we do have this thank you, but we're going to basically from there do a breakout. Let me see what we have here. A lot of this kind of goes over the same details, but I think I'm going to just stop and take a quick pause and see if there's just any general questions about Blockade, integration we have with Sui, anything else that I didn't cover that you'd like to hear more about.
Hi, thank you for your presentation. And after watching it, I think that it is good, but it can be more detailed about on Sui. For example, on the Sui, I think that there is nothing like the approve or revoke the approve. But instead, if a user sign a transaction, it is a transaction recording all the objects, for example, the version, the digest, such information. It is a one-time signature. It is it is something not like the hook on the EVM. So maybe you can develop some feature that can, if a user want to revoke his transaction, you can just simply let him do some random transaction to change his gas coins digest that can prevent the former transactions that can make the former transaction be unusable. That is the first thing. And the second thing is that we also work as an incubator. We have seen that many early stage projects, they launch their mainnet or launch their website, and then unluckily they found that their website is tagged as malicious in the Sui wallet, and that may do some harmful to their development. Whether we can have something to make it more easy to report it is a false positive case to your team to make it flag as normal website to help them. Yeah, that's the two things.
So real quick to that answer on reporting, we do have a report.blockade.io thing. So if anyone at any point is running into a false positive issue where they're like, hey, basically someone seems to be flagged for the wrong reason, you can always come in and report it as a scam and say, hey, like this is a false positive. We want to make sure that this is flagged as something that you remove. So we have an on-call team 24/7 that's always like monitoring this and can respond very quickly.
So if we report that is a false positive case on this website, you can respond very quickly and remove it from the wallet, including the Sui wallet.
Exactly.
Okay, that's very helpful. Thank you.
Yeah, and then to the other points, this is definitely why we wanted to make an open conversation of like, I am an amateur Move expert. We have other people in our team that have dug a lot deeper, but I definitely wanted to hear like we definitely don't see unlimited approvals on Sui specifically, but when it comes to like other things in Move, like what are things that Move developers would be like kept up at night and they would want a monitoring solution for. So appreciate the feedback, and then if anyone else has more to add. Sean, did you have something?
I took note of the transaction verification thing. It's an interesting thing.
Yeah.
Just like if you just split the coin with 0, it changes the version, then you cancel.
Yeah. Just using this method to revoke any transaction. Yeah.
Yeah. One of the things I was going to mention on that topic. I'm Sean, by the way. I work at the Sui Foundation on the security program. And so Max, who is over here, and Reginaldo at Miston Labs.
have built out a lot of tooling internally, as you talked about, specific to Sui Wallet and looking at transactions on Sui Wallet to do threat detection, essentially. That workflow still exists, so it's not, yes, reporting to Blockade is good. What perhaps is also a good idea is reporting to Sui Foundation to our security email address. We have security@sui.io. The reason I suggest that is because the tooling that we have looks not only at Blockade for threat data, but also internally developed intelligence and other vendors as well. And so if, for example, Blockade isn't blocking one of these new tools or teams that you're talking about, they will come back and say, hey, that's clear, we're not blocking it, but actually the Sui wallet, other threat detection data might be blocking it. So, so for everybody, feel free to reach out to us by email if you have any questions or want to collaborate further.
Yeah, and if it is us, they'll reach out to us and get it done as quickly.
Less of a question, just wanted to point out an interesting thing. So I'm Max. I originally built our anti-scam stuff before we got Blockade and Chambertron and other folks involved. And we built, our own kind of internal tool. And what we found, what's interesting is you can't defeat the scammers, right? They're going to constantly evolve, but we're not the only chain, right? We're not the only wallet. And there's a fixed number of good scammers, right? There's a fixed number of nation state groups. There's a fixed number of high level good criminal groups that are building SDKs. So you don't actually have to, like the analogy is you don't need to outrun the bear. You need to outrun your friend. So we have actually seen this, that if scammers are profitable at all, they will continue scamming. And the profit may be like $100 because the cost may only be like a couple domains. But we've seen certain scammers that we have blocked consistently, thanks to Blockade, thanks to our work, for a month or two straight. They at least have stopped doing that scam. Now, other scammers still do it, but those scammers, I don't know where they went. I don't know if they went to Starknet. I don't know if they went back to Ethereum. But the important thing is there are other wallets on the chain. There are other users on the chain. And if they can find a way to get their scam to be profitable, they will still continue. So we've seen a specific scam group actually now block Sui Wallet and offer for you to use a different wallet that doesn't have Blockade integration today. So it's important as an ecosystem that we have to make it so annoying that they go somewhere else, because we'll never defeat them if they are constantly targeting us as an ecosystem. But we have seen good examples of this working. So if we tighten up as an ecosystem, we will probably have less of a scam problem.
Yep. And we have a specific partnership to provide this to all of the major wallets in the Sui ecosystem. So this is something where the system has basically been built to offer wide coverage. We just need to do the integration. We're already talking to a lot of teams. But if you know of a Sui wallet that hasn't heard about us and doesn't know this capability exists, let them know, because we'd be happy to talk to them and get it integrated. And it's likely going to be a process that's already been streamlined for them. I don't know if there's anything you want to add to that, Meg, but she's the person who's been doing all that cat herding so far.
Yeah, maybe I'll just say, Max, 100% agree with what you just said. And if there aren't any more questions, then I would like to thank everyone here. First, the Sui team. Thank you so much for being amazing partners again. Thank you for facilitating this workshop. And thank you, everyone, for your participation and for the feedback. We're going to transition into a more partner-collaborated session in a few minutes. So we're going to ask some of the partner organizations to stay in the room and get into some hands-on discussion. And then if anybody here is interested in speaking with the Blockade team, we've got Nick in the background. Nick, raise your hand. Raz back there. And would love to continue talking with you here at Basecamp or at the event and see how we can support and protect your users. So if our partners can move over to the front rows, that would be amazing. And otherwise, I wish everybody an amazing week ahead and great meeting you.